So this part here is kind of slick. We've got the P-channel MOSFET, we've got resistor, we've got an N-channel MOSFET, and then it goes background to ground. Raspberry Pi can only give about 3.3 volts. And this N-channel MOSFET here turns on, I think, at like a 2 voltage gap, or 2 to 4 voltage gap. I think if I put a high resistance here and a low resistance here, most of the voltage drop would happen across this resistor. But I think there should be some resistance here, so that the voltage here is, the voltage gap here is enough to turn on that MOSFET. I'm considering the safety of like, well, what if this line was 12 volts? And how much resistance here would protect my Raspberry Pi? But honestly, I don't see this side getting to 12 volts. I don't think this section will get to 12 volts, so I think 1 kilo ohm there is probably fine. And I think the Raspberry Pi's 3.3 volts isn't that high, so I think putting 0 kilo ohms here would make sense. If I put 10 kilo ohm here, the voltage here might be like 1.1 volts, which isn't that much higher than the Raspberry Pi's 3.3 volts. And the MOSFETs may benefit from a larger voltage gap, so I might put 20 kilo ohm here. Okay, and as far as this line here, I added this line as I saw it on expressions of other MOSFETs, which I think is kind of like a way of enabling additional charge in reaching the ground. According to this guy, max amp in is 0.5 milliamp, special thanks to Bruno Brunowski. So if I make this 100 kilo ohm, and I say 12 volts here at 120 kilo ohm to my Raspberry Pi, gives 0.1 milliamp, I think I should be good. Okay, now it's time to redo this breadboard. Also, I think I'm going to put a diode here just for the sake of safety for my Raspberry Pi.